Electrical circuit analysis, B and B Tech students. Dot root analysis of coupled circuit problem, and magnetic circuits and ideal transformer apply in circuit problem. This question shown in figure that consists of three loops, loop 1, loop 2, and loop 3 considered. Loop current I1, I2, and I3. Entry point is shown in figure. First coil entry point in dotted area, and second coil entry point in dotted points. The third coil leaving point is dot area. Find the current of the capacitor in the network. K is 1. We already know K ranges 0 to 1. I1, I2, I3 are the loop currents. I already explained of coupled circuits formula as for two coils are same dotted points in entry points. Formula V1 and V2 is given in backside of page L1 di1 divided by dt minus M1 to di2 divided by dt. Self-inductance opposite that is mutual inductance opposite the self-inductance put minus sign. So V2 is L2 di2 divided by dt minus M1 to di1 divided by dt. Minus sign M for M1 to put mutual inductance opposite the self-inductance. Entry points, two dotted points are and two coils available in two entry points. Find the reactive power in using loop 3. We already know K is 1. First, to find mutual inductance between the loop 1 and loop 2, JX12. We already know formula in previous classes. We explained mutual inductance M is equal to K root of L1 into L2. Using that formula, we obtain between the mutual inductance of the coil. M is K into root of L1 into L2. L1 is first coil self-inductance, L2 is second coil self-inductance. So a mutual inductance between the two coils JX12 between the 1 and 2 coil is JX12 is K into root of L1 L2. L1 is in this loop 1 J2 ohm and L2 is J3 ohm. So J2 J3 put. We find out answer is J2.43 and yeah. Mutual inductance between the 2 and 3 coil is JX23. Put formula K root of L2 and L3. L2 is J3 ohm, L3 is minus J5 ohm. Put in this formula, we obtain J3.46 ohm. Mutual inductance between the 2 and 3 coil is JX1. 3 is for using formula K root of L3 L1. Put L3 is minus J5 ohm and L1 is J2 ohm. We obtain put complex to polar form. Answer is J2.83 ohm. Then form loop 1, loop 2 and loop 3 equations. Form the loop equations using coupled circuit formula. Two entry points, two dotted points are two coils. Situation at entry points. Formula already I given. Dotted points are situation at entry points. In two coils, formula is V1 is L1 di1 divided by dt minus M1 to di2 divided by dt. Minus sign for mutual inductance, that is mutual inductance opposite to self-inductance. That formula is used in all circuit problems. That is given in last page in this video. First, to form loop equations. Loop 1. Loop 1 consider 100 volt supply. So 100 angle of 0 and 2 ohm plus J8 ohm plus J2 ohm. That is 2 plus J10 into, that is dependent on the current loop current I1 and 2 mutual inductance between the 1 and 2 coil. Loop 1 equation we form loop equation method and coupled circuit dotted point method formula and current direction depends upon the current direction form loop 1 and loop 2 equations. Loop 1 consider 100 volts and 0 angle of 0 supply and J8 ohm and J2 ohm and 2 ohm resistance. So 2 plus J10 ohm, 8 plus 2 J10 into I1 current minus reactance between the coil 1 and coil 2. We find out previously, that is J2.45 minus sign for put opposites, mutual and opposites, self-independent formula. I address one couple circuit formula in this video last page I given, and then minus j between the mutual and between the coil. Coil 3 and 1, because 3 coils in this couple circuits. Loop 2 consider 50 volt angle of 20 degree volts and 5 plus j 3 plus 7, that is 10, 5 plus j 10 in the current I2 minus of j mutual inductance between the coil 1 and 3, then minus of mutual inductance between the coil 2 and 3. Then the current in the circuit is leaves. So that is minus direction. Leaving point current is minus. Minus into minus plus. So plus j 3.46 I3. Kindly loaded last term. Last term of loop 2 second equation. Loop 3 consider 0 volt supply. So 0 is J4 ohm and minus J5 consider. J4 minus J5 current is I into I3 loop current. Minus of mutual inductance between the coil 1 and 3 and minus of, that is formula, couple circuit, mutual inductance between the coil 2 and 3. I1 current at entry point, so minus sign, and plus j 3.46. How to obtain plus sign? Formula, couple circuit formula is minus j 3.4 I2. I2 current leaving point. Leaving point current is minus. So minus into minus plus j 3.6. So plus sign obtain. Loop 2 and 3 current leaving. So plus obtain. That is, in this way we obtain loop 3 second third equation. In this way we form loop 1, loop 2, loop 3. Couple circuit formula use minus for mutual inductors. Then current formula is considered minus into minus plus sign. Put plus j 3 last term. Solve for I3. 3 equations solves, find out I3 values. Polar complex form use. I added a gas explaining how to form complex to polar and polar rectangular formula using calculator. I explained in previous classes. I3 find out 6.1 angle of 49.44 ampere. Reactive power is find out in loop 3. Reactive power formula is I square into reactance. So in this loop, I3 is current. I3 squared into x. X is J4 minus J5 in loop 3. So put I3 values, complex algebra method, find out using reactive power is minus 37.58 watts. Answer, that is solutions for dot rule, coupled circuits formula is last page I given, that is used, and loop current method formula is used, and current directions and leaving point is minus. So minus into minus, mutual inductance direction minus, and current directions leaving point is minus into minus plus. So last term in equation j 3.4 is plus, that is reason. Minus into minus plus. That page kindly show that formula only used in dot equations. That self-inductance opposes the mutual inductance. Mutual inductance opposes the self-inductance. In this class, we see dot, couple circuit, magnetic circuit, ideal transformer. Thank you.